Yeah, welcome to the 25th virtual meetup, folks. Yeah, before starting, a huge shout out to Browser Stack, our exclusive sponsor for all our community events and premier sponsor for our conferences.
Hey, hello. Can you hear me?
Yeah, Tony, you can give us a quick intro and then we are good to go.
Sure, Arun. Thank you for that. I won't say my name. Everybody knows that now. I'm having like 14 years of experience. I am not saying that I have whole 14 years experience in QA only because I'm experimenting a lot, and I do experiment a lot with my skill sets and career. So I would briefly say that I mean, right from API, mobile, web, desktop, anything I have tried out over there. Name a tool, and definitely I have given some thoughts or maybe some implementation of that. I mean, so that's I'm very curious to know things what is happening in the technical community because that's our bread and butter, right? So that's my focus basically, although I am a QA, and but I'm also working on some of the aspects of AI machine learning projects as well, when I'm helping team members to resolve their queries and work with them, and I'll give an additional angle of QA to development team as well, even though I work with them. So I'm working with MSCI at this point of time, and as I said, I'm experimenting a lot. So basically, along with that, I'm writing a book on generative AI, and that book is not going to be only cover what generative AI is, but how exactly internal workings of generative AI gains and all those things. So basically, my focus is always technical focus. So that's about me in a nutshell. I mean, if you want to know more, you can reach out to me on LinkedIn, but I don't want to invest a lot of time over there and in talking about myself. But yeah, that's me. If you have any questions, as Arun mentioned, you can reach out to community or maybe on LinkedIn if you want. However, happy to help. So that's about me. Screen real quick. I am, to be very honest, I'm not a good PPT maker, or I'm not a great fan of PPTs. So I have just used Google Colab over there. I don't know how many of you know Google Colab, but this is a service provided by Google wherein you can run your Python code. And over here, I mean, it's if you know about Jupyter notebooks, if you don't know, read about it. That's interactive. Interactive Python, I can say. I mean, you can write. Okay, let me show you one command, and I'll start from there. So if you go and let's say print hi, okay. Again, make sure your syntax is correct because um, I don't know how it goes and suggest intelligence through this. Yeah. So about something about this session, I wanted to highlight that, to be very honest, 1 hour is too less for this because there are a lot of internal things which you may need to understand when uh, when you are working on deep learning or AI systems basically. So, but from this session, one sad news for you is that I'm sure you will not understand a lot of things if you don't have that background. I'm making a disclaimer, but if you have that background, um, you will understand a bit of it. But a good news is there, you will learn a lot of new things today. Even if you don't learn, you will get an information around that part, and obviously you can reach out and we can have some further subsequent sessions on this. But whole point of talking is, I mean, don't feel bad if you don't get anything, because there might be people who don't have any background of understanding how internally deep learning system or AI system works basically. Okay, so feel good about it that even if you don't know, you will get something out of it, which might be a new tool. At least you will understand, and you will get to know what it is. So basically, Google Colab, in the very first statement I said, Google Colab, again, it's a freely available. If you want to buy or purchase its premium version, it will give you more RAM and more runtime, TPUs and GPUs, all those things it will give you, but we don't need it, to be honest, at least for practice purposes. Now, One more disclaimer: if you want to really want to train a AI model or deep learning model, you need to have a lot of resources. It's not individual's task, just like us, I, me, you. I mean, we cannot actually, train at our home. We need a lot of resources to train them. So Google Colab provides us a nice way to start with. It will help you with pre-installed libraries like TensorFlow and Keras. So I have used these libraries in my code as a demo code, which I will show you now. Uh, I'm just going random, by there is no structure to follow this, but I'll just come to the point very real quick. Okay, now what is TensorFlow? TensorFlow is Google's open source machine learning library, okay, which is doing a lot good, lot better in terms of machine learning. They have redefined a lot of things and made it open source. That's how I think uh, big giants do. They keep it open source. Okay, and apart from that, Keras is a deep learning library which sits on top of TensorFlow. Okay, so basically over here again, Google Colab only works on Python. Jupyter Notebook may work on R language, Python. There could be Scala. I don't remember all the languages now, but yeah, but this only supports Python. So if you have any knowledge of Python, then only it's helpful for you. Otherwise, you need to read about Python as well. Okay, so now we'll start with like AI. Everybody knows, like we are talking about AI, um, you know, but basically, majorly all those models which are AI models are using deep learning in a nutshell. Okay, deep learning is basically a subset of artificial intelligence, and if you see, traditionally they were only image generation, image, sorry, not generation, generative models are recent. I think it started from 2015 somewhere, and those were not enough, good enough to do things. But recently, I mean, in last 2 to 3 years, there's a lot of advancement over there. But again, previously, deep learning was used to majorly focus on classification and image recognition and natural language processing and etc. But these libraries will cover generative AI as well. So I have taken one example of image recognition in this code, and this will help us to understand the basic building blocks of it. Okay, so basically, what is deep learning? Deep learning, in deep learning, basically it consists of a layer of neurons. Imagine it is not developed on uh, just like human neurons work, but it is a reference from that. Okay, so basically what happens is, in a neural network, so neural network is a base of any AI model or deep learning model. Okay, so um, so what happens basically is, there's an input layer and there are hidden layers. So, and there's an output layer. Now what is input layer? Input layer, as the name suggests, the inputs which are provided by us, the test data, I can say, just for understanding it better. And the hidden layers basically do the job for us. Okay, and hidden layers, there can be n number of layers depending upon how complex the system is, or how perfect you want to build it. Okay, so if you have more hidden layers which will transmit the data through neurons, and those neurons will process information from one neuron to another, and it will rectify it more, it will beautify it more, so that you get the output as the desired output. Again, as I said, I mean, to train these models, it's not fairly simple or easy to do. There's a lot of things which go in the background, and I mean, there are a lot of. Imagine some person. Okay, imagine you. I tell you, I show you one image, and I ask you to, say about it, that what exactly it is. So what you will do if you know to that image? For example, I'll show you a bucket. You will say, or a car. You will say, this is a car. Okay, but this is a bucket. But imagine something you have never seen. Okay, so what you will try to do with your brain, what you will try to do, you will try to recollect all the information you know about things. Okay, imagine something which you have not seen for prior to prior in your life, then probably you will try to recollect from your thoughts, from your information, that what it can be. Okay, imagine there is a stone in water, which some may feel it's a crocodile, but some may feel it's a stone only. Okay, but you will never know until you see it clear enough. This is not a good example, but you can judge, crocodile and stone as well, but I'm just giving you one random example that how you can think through it. Okay, so these neurons basically pass the information, and from there the output comes, and these are very I would say critical or maybe hidden layers. That more hidden layers means more robust system. Okay, not always, but that is the understanding, at least the basic understanding. Deep learning, as I said, I mean, it's a subset of AI models. So, moreover, whatever you find in AI, most of the things happening right now are based on deep learning models only. And again, see what happens basically is, I saw a couple of questions in the community as well. People are really confused about testing AI or AI testing. So basically, these are two different things. Testing AI is something in which you are actually testing the internal working of the AI models or deep learning models, which we are talking right now. And the other portion is, with the help of AI, you test your application. Okay, so these are completely two different things. Don't mix them, don't get confused. It's fairly simple, and to understand basically that what is testing AI and AI based testing. Okay, so now testing AI is these systems are very much difficult to test as black box. Okay, and I saw Ganesh showed us a PPT in which
Tony,
yes.
sorry to interrupt. Can you please zoom a bit your screen?
Okay, let me know. Sorry for that. I
Yeah.
didn't know. Let me know if that is okay.
Yeah, folks, is it visible now properly? Can you type 0 and 1 in the chat? Perfect. Thanks. Thanks, folks.
Okay, yeah. Thank you, Arun. Sorry for that, guys. I didn't know. Um, okay, so basically, I was saying that Ganesh showed us a pyramid of testing, how testing works. I hope that you guys have understanding of, or maybe at least the definition knowledge of what is white box testing, wherein we check the internal processing of any application. Okay, there can be multiple ways in which white box testing can be performed or carried out. Now, in this artificial neural network, as I said, there are a lot of hidden layers which are there. So the the definition of white box testing, one definition could be, now how it that to get it more accurate, it must pass through more layers and more neurons are covered. Just like in white box testing, we test more branchings. Okay, like if else condition, all of them are tested or not, the case, the switch cases and everything, if they are covered, then we are confident that white box testing is carried out and it is a good software. Okay, just like this, the hidden layers and the neurons which are there, right? Those through how many neurons it is passing by, and the neuron coverage, basically that how much neuron coverage is done so far. Okay, so this is one of the way to test these models. Okay, and other thing, there's one more thing, we can compare two models which are trained and tested on the same data source, which can give us the output that, okay, this model A is giving me like 33% of accuracy, but model B is giving me 35. So, and again, that let's compare our model C, that if it is giving us less than that, then probably we need to work more and have to be more good at redefining the neural network. Okay, now, again, the need of effective testing. Again, as I said, I mean, testing is all needed. Imagine that generative AI. I know everybody knows about Chat GPT. Okay. Now, imagine that you created a good documentation using Chat GPT, and at the end of the day, you are fooled by AI hallucination. I mean, you wanted something, it gave you something else, but you don't know about that topic, but you still wanted to be a hero, and you gave a presentation, and you are on the losing side of it. Right? I'm just making one example, so don't feel bad about it or wrong anything in this. So yeah, but that's how it is important to test it, and it is very complex to test it. But if you know, read more about it, uh, as you progress, you learn more about things. um, so traditional testing is not going to help you out here. If I ask you to test chat gpt, then somebody will go and check the UI. That is not chat gpt testing. That's We are just testing the UI. Chat gpt is not known for its UI. It's just a means. Actually, chat gpt, if you want to test it, we should test the internal working of it. Okay. So deep explore, I'm going to. So basically, first of all, deep explore is not the not the last or only one framework over here, but it's the first white box testing framework, um, which is designed for real world testing of deep learning systems. Okay, but again, talking about this, as I said, I mean, these cannot be covered in one session. Definitely, it's a very vast topic, and a huge number of libraries. There are certain libraries which can perform only certain tasks. Deep explore its own way, and it can do some testing in its own pattern. There are more libraries which have evolved, like shap and lime and deepnet, all those things. Okay. And there are many more, okay, which do perform some sort of testing, or maybe in some use cases you need to uh, use one particular library, or maybe you need to mix these libraries and create a framework around this part. But yeah, but we are only for now in this, in the context of this session, we are going to introduce you to deep explore, which was the first framework which was designed for this. Okay. And so basically it introduces you to neuron coverage. So as I spoke about that, how white box testing can be performed over there, and what could be one of the definition of white box testing in AI models. So basically this can generate test inputs, and it gives incorrect input as well to to the model, and it gets the output of it, and these model will, at the end of the day, will improve the accuracy. So neuron coverage I spoke about. I'll skip it for now. If you have any questions, please ask there. Whatever I can answer, I will answer there. Deep Explore identifies error in deep learning model by using multiple DL systems. So, which I again talked about that. Let's assume there's a model A, model B, and model, you are creating a model C on similar lines. Okay, then probably cross-referring oracles means A/B testing, which we call in what we call in our testing world. Okay, so it does that portion as well. It compares the output of one model and with the same input, and talks about um, the other model's outcome as well, which will suggest the discrepancy, and from there you can decide that wherever model is going on. So without, you know, you without any manual intervention, or I mean, you have to be reliant on the technology for that. Okay. um okay, in between I okay, I'll explain you this particular code, and I'll show you one image. Okay, I'll start with the code first, and then probably we'll understand this code. I know there could be there can be many questions over here till now, but this is what I have tried to cover the theoretical part in very basic and layman term, so that everybody can understand that part. I spoke about Google Colab. If you have any questions as well, you can ask me over there. You can use this. Just simply go and do Google about Google Colab. It's free. It's shareable. I can share this document with everyone if I need to. I just simply I have to click here, and I have to pass on the names basically, and or maybe I can create a link and share with you. I'll give you the link at the end of the session, or I don't know how, but yeah, I'll do it. um, then again, just to introduce you to this Google Colab as well, again, coming back over here, you can provide that, you can upload any data over here as well. So for example, I uploaded this sky image. I'll show you this image as well. I'm not sure if it is it can be um, shown directly from here or not, but uh, okay, I'm sharing one. um, Let me open this image. Is this image visible? Let me share this image with you from where I can share. Okay, never mind. So let's go. I'll talk about this sky image, simple sky with clouds. Okay, imagine that, just an image with sky and having some clouds. Now, what we are doing, we are importing TensorFlow library. We are aliasing it as TF. As I said, TensorFlow is a machine learning library which is provided by Google. It is open source. You can use it. You need to install if you're on local over here on Google Colab. It's already installed. So I'm just importing it, and from TensorFlow, I'm importing Keras application VGG16 and RESNet 50. Okay, so now what is this? These are the two models for image. One second, there is. Just give me 1 second. I'll be back. Give me 1 second. Sorry, guys. Just give me 1 second. Sorry, there was a visitor. Okay. Yeah, so these are the two models, pre-created models, from the TensorFlow. Okay, in the TensorFlow and Keras applications, basically in the Keras, and VGG16 and RESNet 50. So these are trained on ImageNet database. Now, what is ImageNet database? ImageNet database is compressing of a lot of images. Okay, it is trained. It is a data set wherein you will find lot many images, and on that images these models are trained um, to predict what is the input image which you are going to provide. Okay, um, and from TensorFlow, again, Keras library, we are importing image module. Now this image module, what it does is it performs the image based operations, okay, within our code. From VGG16 model, we are importing some decode predictions and pre-processing inputs. Okay. Now these will be helpful for us to predict the image and provide us the details, which are going to predict our image and decode our predictions. NumPy, it's numeric Python. We are aliasing as NumPy. So now, why NumPy is used here? Every image can be seen by Python as by pixels. Okay, every pixel is a number. Okay, and NumPy converts every image into zeros and ones. Okay, so that's in a nutshell. I can talk about it. You can read more about it, but NumPy, it's not only limited to converting those images to pixels, but it's a very vast library for numeric Python. It have a lot of functions which do deal with um, uh, numbers in Python, maybe matrices and a lot of formulas, probability, etc. Okay, now these are our pre-trained models VGG16 and RESNet 50, which is again available in TensorFlows and Keras libraries, which are simply calling, and which we are it's as good as defining a variable. Model 1, now model 1 load with VGG16, where weights are ImageNet. I mean, I want the explicit model which is trained on ImageNet. So I'm trying to have both on a similar fashion, so that our accuracy or maybe prediction should not go wrong because of any other um, inputs or maybe variables associated to that model. Okay, the next function is preparing our image. So as I said, I mean, I have uh, put a sky image with clouds. It's basically a sky image with some of the clouds. So I'm just um, importing that image, and I'm importing that in this particular size. Okay, and this is basically a method. I'm passing the image over here and calling this method, and over here image array, image to array. So I'm converting this image to array. Basically, as I said, I mean, everything in uh, Python can be seen as numbers. So image can seen in 0 and 1 matrices. So again, this image array is we are converting it to a NumPy dimension, and wherein we are providing the details over here, and this will return our uh, pre-processed image. Okay, in a variable which we called as input image. And again, so basically we already have an input image, we are just exercising it to be converted in shape and form of Python. Okay, so basically this is our input image, and from here we are using the predict method which is already defined in these models which I spoke about, VGG16 and RES15, which we have imported over here, these methods. Okay, so we are using these methods already in our code, and we are inputting the image to get predictions. Now, now this, after running this will obviously have some way of some values into it. Okay, some prediction usually goes in percentage, so that's what goes here. Get top predictions for both models. So basically top prediction means what happens basically is when there's a prediction goes, prediction is not a single thing. Right now imagine go circle back to the example which I gave you of a crocodile and a stone, right? So you can predict crocodile, you can predict stone, and you can predict anything else as well, right? Maybe somebody say a piece of wood, maybe somebody say a turtle, right? But there would be some percentage, right? When you can say, okay, it's looking like 90% crocodile, but 10% is looking like turtle or stone, however. So I want to get the the top predictions. I mean the top three out of it. Okay. So sky, um, from sky, imagine in this real example, what you can see, what you can predict from the sky. It can be a parachute, it can be a tower, big tower, it can be um I don't know, aeroplane. I'm just making it up. Okay, so just like this, you will get the top three predictions from both the models. Okay, and from there, I'm just trying to print from this VG16 what are my predicted models and give me the percentage of it, up to 2 decimal points. And again, RSNet, I want the prediction for this same. Okay, so now I ran through this code, almost I'm almost at the end. Now again, to compare it, as I said, I mean, these predictions or these images, we have to use NumPy for mathematical operations over there. So so if we are comparing, if my prediction 1 is not equal to prediction 2 and I'm converting them in NumPy, and wherein we will highlight the discrepancies found in model. Now model 1 predicts something, but model 2 is predict something else. Okay, and otherwise just print that okay, both the models are good at predicting the same thing. Okay, so now what is the outcome of it? So basically, when I went and loaded these models, okay, so obviously these will be downloaded from this TensorFlow website, okay, which which have details of these models. These were downloaded, and it took some time. Maybe it depends, right? If the model is heavier, it takes more time. Again, depending upon how much CPU and RAM and everything you have, but but this is how it goes. And obviously you can break this code in sections as well. Okay, let me show you one. um, Let me just copy this and shift. If I press shift enter, it will run this piece of code, and if it is a green right here, it is correct. Okay, let me make something wrong. Again, this is passed because there is no error found, but okay, let me just do this. This might fail. Yeah, this is failing because it says what is TensorFlow question mark. I don't know. Okay, invalid syntax. However, okay. So now this is how it you can. This is how it interactive it and here over help you can find the commands. Now when I load this model, given it is already loaded and my session is still connected, again if your session is disconnected, you can go here and see the commands like manage session, view resources, disconnect and delete runtime, show executed code history, focus on last run cell, connected to hosted runtime, etc. Connect to a custom GC VM. So basically, if you want this collab to work run on some other environment, then you can change via these. Okay. So when I went here, when I imported this particular code, now again this is not going to download because in this runtime we have already downloaded it. It may take some time to over here. Over here it stores all the files, so it is going to store in your runtime session. Again, this uses your Google Drive, so whatever data you are putting here, um, first it will be only applicable till that runtime is active. Second, it uh, if you are storing somewhere on drive, then this will occupy that space, so make sure that you are utilizing it in a nice fashion so that you are not running out of memory. Okay, so this is how you can execute it session by session. Okay, and you can put text just like this. So basically if you go and say hi tribe, okay, so it will show you. So when I go out of it, you can see it will simply say the text. Okay, so that's how you can write in details about it, so you don't have to go anywhere. It's a collaborative tool. Tomorrow let's say that somebody from the tribe is using this and writing something for someone else who who might whom it might be useful, then probably you can do this and you can provide your comments and markdown as well. So yeah, so that's how it goes. Coming back to this now, I'll just zoom it a little bit. Yeah, so top three predictions by model 1, which is VGG 16 model. So it's saying geyser. I don't know why it is saying geyser, but yeah. So what it is defining boiling nature, domestic water boiler in South Africa. That's how they called it. I don't know, but I don't know why it is calling it as a geyser. But it is predicting 19% of a geyser, a parachute 7.53%, and obviously I don't know what is that, a tall square tempered stone. Okay, so 10% it is predicting that. So that is model 1 how it's predicting, and model 2 uh, is predicting your parachute as 29%, and again traffic light 6.4. I don't know why it is sky. So again the answer over here is why it is not giving us the correct I can say output is because these models like VGG and RESNet might not have it only took like these memory, this much memory. Okay, so obviously these are for the demo purposes and it have not trained well on trained a lot. I'll tell you to I was training a generative model, so it took like 3 days to train it on Google Colab, wherein I have to um, make sure that my computer is not off and all those things, and Google Colab is not getting disconnected. So that's how much time it takes basically. And even after doing that, it it didn't give me a, a happy answer, happy generative image of it. So obviously, I mean, it takes, imagine, just read about chat GPT, that how much storage or how much processing power it uses, or how much training it costs to them to train these models. So basically the main problem is not about the understanding the models but about training the models. Okay, once you understand them, it is very difficult to train them. So why it is giving incorrect prediction? As I said, I mean, these might not be trained well on its data, so obviously it is giving us the incorrect output, but it is predicting something wherein our model, let's say model 1 is our model, so it is predicting a geyser, and model 2 is predicting the parachute, but the image is of sky, right? So we are not there, right? So we have to improve this model, right? That's how you can perform a basic test on this. So this was just a to b testing. This again is not a neuron coverage testing, because in neuron coverage testing I have to sit and almost train my model for almost more than a week, and then probably I would have been in a position to explain this, and again I needed that infrastructure as well, I mean, which I don't have it here. I have obviously in my office where I use Databricks, which wherein we can change the hosted runtime to as many CPUs or as many processing units as we want. But over here, I have limited resources to show you. But the whole idea is to get you understand or get you feel better about at least uh, about what are the technologies which are used, where to start, and how you can go and create a model at a very small scale. Obviously, to at a large scale, it's not individuals' choice or option. We cannot do that. Okay, we need some organization to help us with the costing which is associated to create an environment. Now this is about it. And talking about again Google Colab, you can create new notebooks, you can open existing notebook. Okay, so if you want to go and open some old notebooks, then probably you go and just you know what I can say, you can go and open one of them. Okay, and so I'll tell you one thing that I'll show you one more thing that this is obviously, I mean, my upcoming book. So I uh, trained one model which was on style transfer. Okay, if you still need this book, turn to collaborate. Okay, sorry, I don't know what happened over there, but yeah. So I'll show you one model which I trained, and I got generated the image of it. It's more of a generative thing. Okay, so basically um, this is a style transfer. This is again a generative model wherein I provided this image, and this is the style I wanted to be applied on this particular image, and this is how it went through. And yeah, so basically this is again after retraining it multiple times. So it took a lot of time to train this model. So why I'm showing you this is basically just to help you understand that it takes a lot of time, lot of energy to train them. But again, I mean, don't uh, feel bad about it. There, at least to start with, you see, you must know how it works basically, and from there you can build as and when any infra is available with you, but you can start small with testing or creating these models. So I for now I think there will be too much to go ahead with. I think I am happy for any Q&A, unless um, if no, I'm not missing anything. I deliberately kept this to this point only because there are a lot of aspects which even if I cover, they will not be really helpful over there. Okay, but this is something as a you can take it as a starting point of this particular session, and obviously I'll talk to Arun and Shashank over there that how we can make it broader. uh, but but I'm happy to take any Q&A. I'm sure if you see, my point is even if you have never didn't get much of the points from this session, okay, or maybe many libraries are there which new to you. So don't feel bad about it, but feel good that at least you are now aware of some of the names which you were previously not aware of. Okay, so yeah, with this, I think I'll pass on for Q&A.
Folks, if you are having any question, you can post that in the Q&A section. I'll pick it up from there. Questions. Okay. The first question is, can we test text generation models similarly?
Yes. So basically, you mean like a Bard or Chat GPT, etc., right? So if that is the question, yeah. So text generation models, yes, you can test. It is only, as I said, it is only one of the library tailor-made for neuron coverage and A to B testing. But there are like other libraries as well, like SHAP and DeepNet and Deep. I don't recall the name, but yeah, there are a few libraries. I'll give you the names. You can definitely have to blend them and create a framework around that part, maybe using that library, and you can from there you can definitely test that. So text generation basically falls in the category of hallucination. Obviously, if your model can generate text, then what you have to make sure that it is not hallucinating. So maybe you are asking about something and it is giving you some other answer. So that's what the hallucination mean in AI. To test them, there's a library called SHAP, SHAP. I don't recall the full form. If you can Google it, you will find answer around that part. But yeah, that is the library majorly you are going to use for AI hallucination.
Perfect. Sessions. Uh, I think there is one question which is asked right now. Can you please share the doc, Rakshita? Yeah, do join the community. Tony, please share the document in the community.
Okay.
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 Yeah. Yeah, Rakshita, you'll find the document in the community itself. Perfect. And Tony, any closing thoughts by the time, folks, you can fill up the feedback form?
Yeah, closing thoughts as in, I mean, to be very honest, I was anticipating there would be hardly any questions. And reason being, I mean, see, I do understand people are curious. I do understand people want to know more, but these are certain things people see. Some of the things which I'm happy to say, okay, that even on your first day, everything will go on top of someone's head, to
Yeah.
be very honest, because I felt the same way in the past when I started working on some of the things, but
Yeah.
that's how it happens. I conducted a session last year in ATA 2023, wherein I was talking about a Databricks notebook testing. Okay,
Yeah.
so those notebooks are similar to this Google Colab over there as well. I mean, to be very honest, the feedback I got that okay, we have never heard of these tools. So
Yeah.
how? I mean, we don't have any questions. So
Yeah.
that was the feedback I got. I think on the similar lines. Over here as well,
Yeah.
things might have gone, but trust me, don't feel bad about it. It is something, you can take it as a zeroth stage. Obviously, day zero, obviously, I mean, I'm sure that some of the things, even many a times when I started, I'll share my personal feedback with you, that when I started working on some of the AI models on the very first day, and in fact constantly I had some thoughts to leave it aside, okay, and focus
Yeah.
on something else. But the whole idea is to, if you are really interested, then stay there. And at the, I mean, obviously it takes time. Even if you talk about learning about software testing, it takes around at least 3 to 6 months to somebody to get good with it.
Yeah.
And obviously, I mean, there are not many opportunities available in the market, at least for now, for such kind of exploration.
Hmm.
But this is, I would say, keep an eye, because this is only going to be the future. Okay, I mean, you will um, you will always find yourself, maybe not now, but in coming days, that you are only paid well, or maybe compared to the current market, or maybe there are jobs available only if you upgrade, right? And the way technology is changing, so I would simply say that everybody has their personal preferences, but or experiences, the, but there is always one thing which I think everybody should be on the side of learning new things. So
Yeah.
just take that as my closing comment, that keep learning, okay, irrespective
Yeah.
of what stream or maybe what line you are choosing to go.
Yeah.
But yeah, be there. And if you have any questions, definitely I'm there to help you out.
Yeah.
Yeah.
You can ask the question in the community.
Yeah, wherever. I mean, community is a good option wherein you can share your images and code as well, wherein you, if you cannot share on any other aspect, it's easy to share the screenshot
Yeah.
over there, and probably from there you can, it's good for us as well, from the community members who can answer to
Yeah.
it nicely.
Yeah.
But one thing I would like to say that I'm not sure how many of you have ever heard of these libraries, TensorFlow and Keras. But if you have not heard of it, but you got to know now at least, then I'll be at least from that perspective, I'm very happy that I was able to share at least some new names with
Hmm.
you, which are part and parcel of this market. Yeah.
Yeah. Perfect. Perfect. Yeah. Back form. Yeah. That is it from our side. I will surely meet you in the next session and in the community, like how we can help you out. Perfect. Thank you. Thank you very much, Tony. Thank you. Thank you.